So simplifying exponents and radicals. I have 3 examples here for you, and this is intended for students who are in grade 11 and want to test themselves before they get started on studying exponential functions. You should be able to simplify, work with exponents, even with radicals, and then radicals are basically fractional exponents, and be comfortable in that flow. And if you're going to take on these 3 examples, you can screenshot them from yourselves, then pause the video, and then actually work them out before I work them out. If you're comfortable with them, great. You can go ahead and then just kind of dive into the world of exponential functions and study those. And those are going to be in the, I guess, grade 11 playlist that I have. I'll put up above there, and then you can search up the exponential functions in. Now, if you're not going to be comfortable in solving these questions and you're going to be struggling and you need a review, so that review is basically, because exponents should have been covered in grade 9 for you at some point. Now, we forget, especially if we don't work with them, or we have a long layoff like a summer or something like that. So I'll put up a link above for the kind of introduction playlist to the exponents from grade 9. And then the radicals, you should be comfortable with working with radicals, simplifying them, and also working with radicals and fractional exponents, because they're the same thing. All right. So on those radicals and fractional exponents, I'll put up a link up above there for you if you're going to need it. All right. So now let's kick off these examples and then see, how well you understand these topics. Here's example number 1. I'm going to copy it down. Let's bring it in here. So in this example, so it looks kind of super complicated, but again, it forces you to simplify and then work with these things. And we're going to try to make the exponents positive if that happens, that they're negative. And I'll show you what that means. Okay, so first thing is first. So I'm going to actually distribute the radical. So what I'm going to do is I'm going to do this. I'm going to take this 512 and then I'm going to take, okay, so this is now 9 and then x to the 27. So I'll do that on top. Now the reason why I'm doing that is because I have a number, 512, and I'm going to take the 9th root of that. All right, and then at the bottom, I'm going to take 256, and then I'm going to take the 8th root of all of this junk. This is actually going to simplify pretty nice. All right, so now I don't know if you can use calculators or not. It's not that I'm always familiar, but I do see that the 9th root, so this one right here, the 9th root of 512 is actually 2, because 2 to the 9 is 512. And you can check that on your calculator if you wanted to. Right? If I pop my calculator here, let's take the the nth root. So this is 9. Let's put the 512 in there just so that you can see it. So that's 2. So that's easy. So this is 2 right there. Now this right here, I'm going to simplify this. I'm going to put it as a fractional exponent. So this is going to be 27 over 9, because that's what the radical actually is, right? It's the fractional exponent. And actually even from there, so 9 goes into 27. So this is 2x to the 3. Okay, so that's already much simpler. Next, the bottom, so the 8th root of 256, that's actually also 2. So you're going to see that. So that's going to fall off pretty nice. And then we're going to get 32 over 8. And the denominator there, so you're going to get 2. And then x, 8 into 32 doesn't, oh, it goes, right? So it's 4. Okay, so this is really nice. Okay, so this just simplifies right there, 2 divided by 2. Now we can, okay, so x to the 3, so it has the same base, while it's division, so it's a subtraction of the exponent, so this is going to be x to the minus 1. And since I said let's keep the exponents positive, so this kind of forces you to remember that this is how it looks like. All right, so this mess that we had right here simplifies to this. And then if we knew what x was, then we can substitute it in. And of course, the assumption is x cannot be equal to 0, because in the denominator, we would have an undefined number. All right, so that's the first example. So if you can do that and understand it, thumbs up to you. Okay, so here's the second example. This one looks even worse. Let's copy it, paste it. Now this, I guess, we already know what A is, so that's 3, and then B is equal to 2. So what I find a lot of students might do is they might just substitute for A and then substitute for B, because they're not always comfortable with exponents. I'm going to actually take this into 2, and I think it's to your advantage. So first, just simplify this entire junk. So whatever we will get, we'll simplify it as much as possible. And then at the end, we're going to substitute these, the 3 and the 2, to actually get a computed number. All right, so let's do that. So I'm not going to worry about the radical at the first instant here. So let's simplify as much as possible. I'm going to bring the numbers all together. So I'm going to have 9 times the 32, then divided by the 2, which is there at the bottom. So I'm going to group those numbers together. And because they're all multiplications, I can do that. And then I'm going to kind of group. Okay, so let's start here. So I have A. Okay, so these have the same bases, right? And it's multiplication on top and then the division at the bottom. So this one is going to be A. And so maybe I'll write it down for you. So it's negative 3, right? It's A to the 3, so it's going to be plus 3. And then minus so there's a 1, okay, above that. So that's what we have there. And then with the B, I'm going to add those in a second. And then for the B, so that's right there. So I have a B, and a B. So that is 2 plus 1 minus, again, negative 2. And so that's going to simplify quite a bit. Now this 2, I'm going to get rid of that 32 there. So 2 goes into 32. So that's going to be 9 times 16, I guess. So that's that. Then for the A, so it's going to be A, well, that's 0. So this is negative 1. And then for the B, I'm going to get 2. That's 3. Well, it's going to turn into plus 2. So that's B to the 5. All right, so this is what I have. So now 9 times 16. I mean, I can find out what that is. I'll leave it because I'm still going to substitute these in here just in case. Okay, I want to simplify things. So maybe I'll leave those numbers there. And then, so let's put it like this. So 9 times 16, and then it's going to be B to the 5, and then it's all over, okay, the A. So I'm going to bring the A at the bottom because it has a negative exponent, right? So that can go at the bottom. Now let's substitute the numbers, which is going to be equal to now 9 times 16 times B, which is 2 to the 5, divided by 3. All right. 3 goes into the 9. Well, 3 times. So it's going to be 3 times 16 times, and then this is 2 to the 5. Now 2 to the 5, if you don't remember, that's 32, right? Because 2 times 2 is 4, then 8, 16, 32. So we have this. And that's our answer. So whatever that is. So we can multiply all of these together. Whatever, I'll just put it up here. So 3 times 16 times 32. I mean, I guess you can torture yourself and do it by hand, but there you have it. All right. So it's pretty neat that this is what we have under there. And then, okay, so I guess I can't forget. So this right here, because I still have this square root at the end. So let's put that square root in here. So whatever that might be. So it's the square root of 1,536. I don't know what that will be. Okay, so there we have it. So this is 39.1 1, 9, I don't know, maybe they wanted you to round or something. So you can round this to the 10th, you can round it to whatever you want, if your teachers asked you to or not, or maybe you just wanted to leave it as a radical like this. All right, but since we have all the numbers, we can actually compute it. So that's example number 2, and hopefully you can be comfortable with that. And here is your third example. This is probably a little bit more challenging because it doesn't have necessarily numbers. It looks kind of complicated. Actually, I think I can work it out here. So let's simplify this whole thing. All right. Okay, so I'm going to take, so this y, and then it's multiplying this. Now it has an exponent of 2n plus 3. This is the tricky part. So we're going to have y. There's a 1 right there, right? So since the base is y, then I'm going to add those, which is going to be 2n plus 3 plus 1. That's on top, so this is the square root of that. Then at the bottom, right there, this one is interesting, but I can actually already, so I'm going to switch the radical because it's the third root, it's the cubic root. Okay, and so that's going to go right here underneath, and that's going to help me quite a bit. So let's simplify this now. Y 2n plus 4. Okay, so that's just adding these. Now let's take the radical. Okay, instead of writing the radical, I'm going to write it as a fractional exponent. So like this. So this is what I have. Now 3 divided by 3, well, it's just 1. So this is going to be y to the n, like that. Now this 2 that you see, okay, it goes into this 2 and then goes into this 4. So I can simplify this. It's going to be y to the n plus 2 divided by y to the n. So that's what I have right there. And now, so if we take this, so if we have, okay, that, I'm going to just write it just above. So that's going to be y. Now it's division, so it's going to be n plus 2 minus n. So notice n minus n, because those are like terms in the exponent. And that just leaves you as your answer y squared. That's it. That will be the simplified form. Now we don't know what y is, so we'll leave it. Y, I guess, cannot be equal to 0, and that makes sense, because if we plugged it into here, that would have made that 0. But that's the simplified version of what you have. And those are 3 examples that, you should be kind of comfortable with doing. Now, obviously, in grade 11, most of the time you probably will do some kind of a review of all your laws and radicals, play around with them. But this is a good test for you. Okay, these ones are probably a little bit more challenging. Okay, thanks for watching. See you in a future video. Cheers.